Hello, welcome to the third session of the Introduction to International Trade, which is Unit 1. I'm your host, Elias. In this video, we are going to look at opportunity cost in more details, and specifically, we will display opportunity cost using the constant opportunity cost structure as well as the increasing cost. So we start first by looking at the constant cost in this video, and then in the next video, we will look at the increasing cost. So let's look at the production possibility frontier, which is also the transformation curve, and this is the locus of points that shows the combination of two commodities that a nation can produce by fully utilizing all of its resources with the best technology available to it. Now, from this definition of the PPF, we can spot out four assumptions. Number one is that the nation is only producing two commodities. So we can say commodity X and Y and whatever names you can give it. And secondly, we see that the nation has a fixed technology. Okay. And we are seeing that the nation is also fully employing all of its resources. And then finally, that the resources are fixed. So whatever resources the nation has, these resources are fixed. Therefore, four assumptions we make is that the nation is only producing two commodities, and that there is a full employment of resources, and that the resources are fixed. Finally, that the technology is fixed. Okay, so the slope of the production possibility frontier is what we call the marginal rate of transformation. And in measuring it, we get the ratio of the change in what you give up divided by the change in what you produce more. So that is the change in the foregone divided by the change in the gain. So consider the production possibility schedule below. So we start with nation A, where we are producing only two commodities, X and Y, and that the production of the numbers, values on X are reducing as you go down, whereas the numbers on Y are increasing as you go down, which means that the more of Y a nation is producing, the less the amounts of X will be produced, and the more the amounts of X the nation produces, the less the amounts of Y the nation will produce. Let's also look at nation B, where nation B is also producing two commodities, X and Y, and similarly we see that the values of X are reducing as you go down the table, and that the values of Y are increasing as you go down the table, which shows that the more of X will call for less units of Y produced. Okay, so now let's consider the graphical illustration that we have a nation A. If we plot the data we saw for the nation A in the schedule, we will realize this graph, and clearly you'll see that the line is straight and downward sloping, which indicates that the nation is experiencing constant opportunity cost. That is, for it to produce an additional unit of X, it will need to give up the same amount of Y for each additional unit of X brought into the production process. So if we pick arbitrarily any point, say point P, and start measuring the slope, you will notice that the slope will be negative, and it will be the same throughout. For nation B, we also see, if we plot that data, we will have this structure, and if we pick any point along that line as our starting point, say P prime, it means that the slope that we will be observing will be constant throughout the line, which means we are dealing with constant opportunity cost. Now the frontiers, which it should be noted that the frontiers are downward sloping, which means that as each nation produces more of X, it must give up some of the units of Y. In other words, there will always be a trade-off along the frontier. And secondly, the straight line production frontier reflects constant opportunity cost. And if we have any other shape, then we are going to describe it according to the structure. For example, the one that is bulged outwards will be said to be reflecting increasing opportunity cost. Let's look at the conditions under which a constant opportunity cost arises. Number one is that the constant opportunity cost arise when resources or factors of production are either perfect substitutes for each other, or they are used in fixed proportion in the production of both commodities. Now, what this means is that if resources are perfect substitutes, the nation can produce more and more of X, and the consumers of those commodities will equally be satisfied by consuming a lot of X and less of Y, because the two commodities can be used in place of each other, or they can be substituted one for the other. And if they are used in fixed proportion, it means that for every level of output that is to be produced, the amount, the commodities that will be consumed have to be taken in at a given rate. So for example, if it means that for you to consume 1 unit of X, you will need 3 of Y, it means that's how it will be throughout, and therefore this will give you constant opportunity cost. And secondly, it arises when all units of the same factor are homogeneous or are of the same quality, which means that given that you consume commodity X and you consume commodity Y, you will equally be satisfied because the quality you are getting is the same, and therefore it means that substituting one for the other in production will not affect your utility. Okay, let's now look at the slope of the production possibility frontier in more details. Here, we are assuming that the nation is giving up some units of Y to produce an additional unit of X. With that, then the change in the foregone will be the change in Y, and the change in the gain will be the change in X. So because for us to produce more of X, we give up some of the units of Y, it means the whole of this ratio will be a negative. Looking at our previous graph, let me just take you there. So you will notice that starting from point P, if I want to produce more units of X, say for me to produce 30 units of X, I will have to give up 20 units of Y. So let's just put a cut somewhere here. That for me to produce 30 units of X, I'll have to give up 20 units of Y, which means that the slope then of this production possibility curve will be 20 divided by 30. Okay, so that's the 20 divided by 30 we're seeing here, and we are putting a negative to show that the slope is negative. Therefore, the more you are producing of one, it means you will have to give up more and more. So the other unit will be, the other commodity will be experiencing reduced units, while the other commodity will be having increasing units. Later, we are going to drop this negative to make sound analysis, because remember, in economics, we treat negative values as economic nonsense because they don't give much direction to what is happening. And if we land in negatives, then we know that there is much trouble in the economy that we are supposed to deal with. Okay, so for nation B, if you do the same and get the slope, you will land at negative 2. Thus, to produce one additional unit of X, nation A should give up 2/3 of Y, and nation B should give up 2 units of Y. Recall again that when measuring the opportunity cost, you have to measure it in terms of the units of the foregone. So in this case, we are giving up commodity Y. It means we are going to measure the opportunity cost of this item in terms of what we are giving up Y. So the opportunity cost of producing an additional unit of X for nation A is 2/3 of Y, and for nation B, it's 2Y. So with the assumption then that commodity prices are equal to the cost of production, it means that then the slope of the production possibility frontier will be equal to the relative commodity prices. Now this means that if I draw the curve, this will make more sense when we come and look at the concave curve. So let me just try to illustrate that so that you see where we're going. So it means that at this point then you will see that the tangent you draw here, which if extended can be used to measure the relative commodity prices, will be equal to the slope of the production possibility frontier. Now in the case of a straight line, it means that throughout the line, the marginal rate of transformation will be equal to the relative commodity prices, and therefore for a straight line, the PPF, we observe that we are dealing with constant cost. So if that be the case, then it means that in nation A, the relative commodity price will be 2/3, while in nation B, the relative commodity price will be 2. Okay, so a nation is said to have a comparative advantage in the production of a good whose opportunity cost or relative price ratio is smaller compared to the other nation. In this case, we can see that for nation A to produce an additional unit of X, it has to give up 2/3 of Y. While for nation B, for it to produce one additional unit of X, it has to give up 2 units of Y, which means that then nation A has a comparative advantage in the production of commodity X, because it's incurring a lower opportunity cost compared to nation B. And by rule of thumb, you should note that in that case, nation B then will have a comparative advantage in the production of commodity Y. So with that background, let's now turn our focus to looking at the basis for trade as well as the gains from trade. Why should nations trade? And if they do, what will be their gains? Okay, so in the absence of trade, a nation can only consume the commodities that it produces. In other words, when the nations are in autarky, consumption will be a subset of production. What is produced domestically, out of it is what the nation, people in the nation will consume. And if we assume that whatever is produced is consumed, then in autarky, production is equal to consumption. And as a result, the nation's production possibility frontier will also reflect the consumption frontier. So which combination then of the commodities the nation actually chooses to produce or consume will depend on people's tastes, and secondly, the considerations of demand. So if tastes are equal, then we will see the implication and people's behavior and how the production possibility curves will be tilting to identify the consumption point. Okay, so now we begin our analysis. Let's assume that in autarky, nation A produces and consumes at a point P. Now that's a point where I'll take you on this graph. So the point P we are looking at here is this point. So if we assume that this nation A is producing 90 of X and 60 of Y. So 90 of X and 60 of Y, while nation B produces and consumes at point P prime, where it's 40X and 40Y. Okay, so from that, if we start with nation A first, we will notice that if nation A is at point P, given the slopes of the PPF we computed, or the relative commodity prices we computed, it means that nation A has a comparative advantage in the production of commodity X, and therefore nation A will specialize in producing commodity X. And from this specialization, nation A will be able to trade with nation B. And if that happens, then we can assume a consumption point. Let's assume point E, where nation A is able to export 70 units of X to nation B to import 70 units of Y. So if such a trade takes place, then nation A will consume at point E. In the similar way, we also have nation B. Nation B is at point P prime, where it's producing 40 of X and 40 of Y. And clearly we see that the slope of this line is 2, which measures the relative commodity prices, and therefore this tells us that nation B has a comparative advantage in the production of commodity Y. With that, nation B will specialize in producing Y, and that is, it will go at point Z prime, and from there the nation then will consume at point E. So if nation B exports 70 of Y and imports 70 of X, then it will consume at point B. Let's measure the production gains from specialization. So with complete specialization in production, the world gains 50 units of X and 20 units of Y to be substituted between the two nations. Now, how are these gains measured? So consider this tabular illustration. So before specialization, note that nation A was producing 90 units of X and 60 units of Y. And nation B was producing 40 units of X and 40 units of Y. If we sum up the total X production, we will have 130 units of X produced and 100 units of Y produced. This is the world production before specialization. 130 of X and 100 of Y. After specialization, we noted that nation A will produce 180 units of X, that's at the corner, and 0 of Y, which means there is complete specialization. And nation B will produce 0 of X and 120 units of Y. If we sum up the X production after specialization, we will have 180 of X produced and 120 of Y produced. To measure the gains, we subtract the X production after specialization minus the X production before specialization. So 180 minus 90, we will have 90, and 0 minus 60, we will have negative 60. We come down to nation B. For nation B, after specialization, X, so 0 minus 40, we will have negative 40 as the gain, and for Y, after specialization, we have 120, so we subtract 120 minus 40, we will have 80 units. And if we sum up these units of X to get the total gains, the net gains, we see that nation commodity X, we gain 50, and in commodity Y, we gain 20 as a result of specialization. Now, the next question we need to answer is then, how are these gains distributed in trade? So just out of specialization, we have produced 70 units of X, extra 70 units of X and 20 units of Y. Now we need to distribute these units to nation A and nation B. Let's look at the production gains, the consumption gains from trade. Okay, so with a trade, nation A consumes 110 units of X and 70 units of Y, while nation B consumes 70 X and 50 units of Y. Now, this should be noted from our previous graph when we went at point E and point E prime respectively. These are the points of consumption. Now, let's try to measure how many each nation has gained. For nation A, remember that before trade, the nation was, let me bring this here, the nation was consuming 90 because domestic production was equal to domestic consumption. So meaning that before trade, nation A was consuming 90 of X and 60 of Y, while nation B was consuming 40 of X and 40 of Y. If we sum up the X consumption and the Y consumption independently, we will have 130 and 100 respectively. After trade, That is when nation A exchanged 70 units of X for 70 units of Y. Our new consumption point was 110 for X and 70 of Y. While for nation B consumed 70 of X and 50 of Y. If we sum up these values, we will have 180 of X consumed globally and 120 of Y consumed. To measure the net gains, we subtract the X consumption after trade minus the X consumption before trade. So we will have 110 minus 90, which will be 20, and then the Y consumption after trade minus the Y consumption before trade. So we will have 70 minus 60, which will be 10, and then we will have for nation B, in terms of X, we will have 70 minus 40, which will be 30, and then 50 minus 40, which will be 10. And clearly, you will see that the net gains in consumption of X will be 50, while the net gains of consumption in Y will be 20. And note that these are the same values that we obtained as the net gains in production due to specialization. So now these gains have now been distributed between nation A and nation B. So nation A will gain 20 of X and 10 of Y. Nation B will gain 30 of X and 10 of Y. And then when we sum up, we see that we are getting our actual gains in production, which is 50 of X and 20 of Y. Okay, so this is the graph that we saw earlier. Now we are trying to add the trading possibility line. So the line that joins the production specialization point and the consumption point is what we call the trading line, or the trading possibility line. Because from here we see that it's able to tell us how many units of commodity X the nation has exported and how many units of commodity Y the nation has imported. So clearly from point Z to point E, we see that nation A has exported 70 units of X and imported 70 units of Y to consume at point E. Similarly, in the same way, we see that for nation B, the trading possibility line is the line joining Z prime and E prime. And it is also showing us how many units of commodity Y nation B has exported and how many units of commodity X nation B has imported, which is 70 units of Y exported and 70 units of X imported. And clearly from here, you will notice that number one, the triangle EKZ is equal to E prime, K prime, Z prime. That is, this triangle here is equal to this triangle here. Why? Because the exports of one nation will be equal to the imports of the other nation. And the exports in this case, the exports of nation A will be equal to the imports of nation B, and the export of nation B will be equal to the imports of nation A. And therefore, this triangle then is what we call the trade triangle. So the trade triangle is bordered by one, the axis of the nation's commodity of a comparative advantage, as well as the trading possibility line. And then we join to form a triangle from the point of consumption. Okay, so secondly, we also see that the international terms of trade here will be equal to the slope of the trade possibility line. So this is the line. This line is showing the domestic or the local terms of trade or domestic terms of trade, while the slope of the trade possibility line will give us the international terms of trade. Okay, thank you very much for watching. If you have questions, please send an email to muauelias.com. I'll see you in the next video.